All right, hello once again. This is Jeff Scott of Rankin Technical College, IT instructor in the Application and Website Development Program. What I have decided to do is, since the next test that we're going to take, which was really supposed to be according to the documentation, be on chapters 13, 14, 15, and 16, it's basically just on chapter 14, which of course you'll also need a knowledge of chapter 12. So I've decided that since there really is nothing per se from chapters 13, 15, or 16, that I would just lecture on the PowerPoint slides for those and make those available to anyone interested in 3 different presentations. So we're up to chapter 15, the middle of 3, how to work with interfaces and generics. And I'm going to concentrate more on interfaces. All right. So use .NET interfaces as you develop classes for an app. Develop and use your own interfaces. Distinguish between an interface and an abstract class. Describe the use of some built-in .NET interfaces. In general terms, describe the use of default methods as well as static fields and methods in interfaces. Describe the use of generic interfaces. Okay. So, why would you ever want to have an interface? I mean, what is the advantage of having an interface? Well, one thing to remember as we get started, we've talked about this before, as you start working with inheritance, it is only possible, it is only legal, so to speak, for a C# class to have only one parent. All right? So you've got a child class that inherits from a parent class, but it can only inherit from one class. What if you created a class and you inherited from a parent? All right, but now you want to have other people inherit from your class. All right, but you really need to add something to the original class, but you didn't write that original class. All right, but you need to have something added to it so that everybody can use it. Well, you can add an interface. Maybe I'm making this harder to understand than it has to be, but let's put it this way. You can only have one class that you inherit from, but you don't inherit interfaces. It's called implement interfaces. All right? You can only inherit from one class, but you can implement 0, 1, 2, 3, 4, or more interfaces. So whereas C# only allows for single inheritance, it allows for multiple interface implementation. Now this is an example, and a couple things about this that look maybe a little different. First, you don't have the word class in there. You start an interface with the word interface. All right, so this could not run by itself. This is not a class. Second, historically, interfaces start with a capital I. So instead of this being displayable, it's I-displayable, and you can see the caseness here. That's pretty much standard, not just in this language, but in other languages that allow interfaces, for example, Java. Then what do we have in here? It looks a little bit weird because all we have in here is the name of a function, get display type, the return type for the function, string, and the fact that it takes one argument, another string that here is called sep. What this means is that any class that implements this interface must provide a function named getDisplayText. It must return a string, and it must take in a string. And if you can understand that, you're on your way to understanding interfaces. So here we've got this product class. All right. And you'll notice with this product class in here, it is implementing I displayable. Since we have this string get display text string. Since this is implementing it, it looks like, oh, that's inheritance. No, because it starts with a capital I, so it's implementing an interface. So you implement an interface the same way that you inherit a class as far as the syntax. But this says that since we're implementing the iDisplayable interface, product must have a method called getDisplayText that takes in a string and returns a string. And there it is. And there's an example of how it's used. It doesn't really look a whole heck of a lot different. All right. Now, some people get confused, and this, as they show on this slide here, the comparison between interfaces in an abstract class. The biggest difference between them, and I don't care what it says on this slide, the biggest difference between them is an abstract class is a class. It is a C# class file. It cannot be instantiated, but it is still a class. An interface is not a class. An interface is kind of like an add-on that you would add on to a class. And you inherit from an abstract class, you implement an interface. So as it says here, both interfaces and abstract classes can provide signatures for properties and methods. Yeah, that's true. Both can implement some or all of their properties and methods. An abstract class can use instance variables, where an interface can only use static variables. Remember? We talked earlier about what is a static variable. A static variable belongs to a class, whereas an instance variable belongs to each instance of a class. All right? But since an interface is not a class, it can't use class variables. And again, when you look at the bottom bullet there, it's what I mentioned earlier. A class can inherit from only one class, whether that's an abstract class or not. But a class can implement multiple interfaces. And when we say multiple, we just mean 0 or more. All right? So with inheritance, it's 0 or 1. With interfaces, it's 0 or more. All right, here are some of the built-in .NET interfaces. Why would you want to use these? Because when you add these kind of things to your program, now everything that these provide is now available to your program. But as an example, if you use the iDisposable, so if you implement iDisposable, you have to provide a method called dispose that returns nothing and takes in no parameters. If you implement the iConvertible interface, you must use the getType code. You must have a 2 decimal and an int32. If you do the iComparable, you must do the compare_to. All right, which takes in an object and returns an integer. And finally, with the iCloneable, you must have a clone method that returns an object and takes in nothing. All right, here's more. I'm not going to read every one of these. You can see what's happening. The one you'd probably end up using, or the ones you'd probably end up using the most often. Cloneable is basically the way that you can make copies of objects, or it's a way of doing it. Comparable is one you could use. If you want to compare parts of 2 different objects, what iComparable will do is it'll return one of 3 values. If the first object is greater than the second one, it'll typically return 1. If what you're comparing is equal, it'll return 0. And if the first one is less than the second one, it'll return -1. All right? But you can use the iEnumerable a lot if you start to work a lot with enumerations. We've gone over what enumerations are in this class. That's when you create your own data type. We haven't done much with them, but you'll find them a lot in actual application code. But ones you might use quite a bit, like iList. Notice what it gives you when you implement the iList interface. Now you've got an add method, a clear method, a remove method, and a remove at And dictionaries could be used quite a bit too. All right? So when you create an interface, as it says here, public interface, the name of the interface, which again starts with an I, and you can have in here static variables if you need them, and methods. This was the simple example that they showed earlier. But now we're using the iDisplayable as opposed to writing that our own display text. So this is using, I think that's one of the built-in methods, the iDisplayable. All right. I'm not going to spend a lot of time on this because, again, this is not part of your test. I'm going through this hopefully to at least start you on the road to understandability to this stuff. Because I figured rather than sitting there and having you watch me read, as an example, out of the book and go through some kind of half-baked examples, I do it like this. Hopefully it's not as half-baked. All right. There's not much more I want to talk about in here. Again, they give a lot of different examples, but we're not doing any of this stuff. All right. All right. Again, they talk in here at the end about, as it says, some generic .NET interfaces, so some built-in stuff. I already mentioned the IEnumerable to you, and there's other ones. The reason that you would implement these interfaces is so you could use these different methods without having to, you can be sure that you've got these methods and you can override them to make them do what you want them to do. All right. This is the comparator that I mentioned to you before. All right. Now, there are constraints, as they mention here, that you can put onto classes. All right. And I'm going to just leave that up there for a second so that you can read it. Again, this is getting really heavy. And I think that's pretty much it. So this is probably going to be even shorter than the last lecture was. All right. So when I come back, let's see. Yes, it is. So when I come back in just a couple moments, I'm going to go over the last of these chapters, and that is chapter 16. And chapter 16 is talking about, this is actually something that's fairly relevant. How to organize, document, and test your classes. And they'll mention things like how to put your classes into a library, how to combine a bunch of classes together, etc. What we are going to do on Thursday of this week is we're going to write a very large console application as a class. And when I say as a class, I mean with all of us. You're not going to have to turn it in. All right, but if nothing else, follow along. Feel free to key it in if you want. Feel free to not key it in if you don't want to. But it's going to show you some of the components and some of the stuff that's in here in Chapter 16. So I'll be back with that discussion in just a couple moments.